my dear students. Let's start the session.
Here, conservation of linear momenta. Conservation of linear momenta. Conservation of linear momenta. Conservation of linear momenta. Next, conservation of angular momenta. Conservation of angular momenta. Angular momenta. Conservation of angular momenta. Okay na? Linear momentum is nothing but P. Angular momentum is nothing but L. Clear up? Focus here. So first ఈ రెండు కేసెస్ ని మనము అనలైజ్ చేయాలి. ఫోకస్ హియర్. సో ఫస్ట్ మాస్. Body 1, mass how much? m1. What is the velocity? u1. This is before collision. Do you know the collisions? Mass m2, velocity u2. This is what? Before collision. You know the collision, the impact. Before collision. After collision. What are the velocity of the bodies? Both bodies move together. With common velocity v. Mass m1. This is mass m2. After collision, both the bodies move together. We can call it as plastic collision. After collision, here u2 equal to 0. Clear? We can call this collision as plastic collision. This is what? Plastic collision means both the bodies move together after collision. Both the bodies move together with common velocity v. It is one of the special case in inelastic collision. Plastic collision is the one of the special case in inelastic collision. Inelastic collision. This is called inelastic collision. Conservation of linear momentum. What is the initial before collision? This is what? Before collision. T1 equal to how much? m1 u1 is the momentum of the body before collision. Next, P2 would be, what is P2? Tell me. Momentum of the body after collision. Momentum of the body, second body before collision. Momentum of the second body before collision. Okay na? So conservation of linear momentum. What is the conservation of linear momentum? Algebraic sum of all the moments before collision. This is initial. That is what? Before collision. Algebraic sum of all the moments, that is final after collision, before collision and after collision. Okay na? So algebraic sum of the moments means what? M1 U1. What is the momentum of the first body before collision? Mass into velocity is the linear momentum. M1 U1 plus M2 U2, that is equal to how much? M1 plus M2 into how much? V. Both the bodies move together. So అలా అనుకోకుంటే ఇలా రాసుకుంటే ఏమొస్తుంది? M1 V1 plus M2 V2. Here V1 equal to V2 equal to how much? V1 equal to V2 equal to how much? V. U2 equal to how much? 0. Now coming to the angular momentum case. A disc or ring, whatever it is, a disc is rolling. A body is rotating about this axis I1. Here it is I1 omega 1. It is rotating about the axis perpendicular to the plane. Another disc is stationary disc. Another disc is what? Stationary disc. So here omega 2 equal to how much? This is omega 2. You can take it as 0. We can take it as 0. This disc gently placed on the disc 1. Rotating disc. This disc is rotating. Okay na? So if you place the disc is gently placed here. This plus equal to this disc is gently placed. Okay na? Disc 2 is gently placed. What is the common angular velocity? Omega. This is how much? I2. This is how much? I1, I2, omega. Understood? Disc 2 is gently placed. Disc 2 is stationary. Disc 2 is gently placed on the rotating disc 1. Then both will rotate at common axial angular velocity, that is omega. Understood? So when you compare these two cases, in what manner you can compare? In place of M1, what is coming here? In place of mass moment of inertia will come. In case of linear velocity, angular velocity will come. Understood? So when you compare exactly same or not, M1, here what you will get? I1. What is the angular momentum L1? I1 omega 1. Angular momentum L2 equal to how much? I2 omega 2. What is the kinetic energy? And rotational kinetic energy how much? Rotational kinetic energy how much? Rotational kinetic energy of the disc 1 of I1 omega 1 square. What about kinetic energy 2? Kinetic energy 2 equal to how much? Of I2 omega 2 square. I2 omega 2 square. I1 omega 1 square. What is the kinetic energy 1 here? What is the kinetic energy of the first mass? Of M1 U1 square. What about kinetic energy 2? Kinetic energy 2 equal to how much? Of M2 U2 square. What is the law of conservation of angular momentum? Law of conservation of angular momentum. Law of conservation of angular momentum. Law of conservation of angular momentum. What is the law of conservation of angular momentum? Algebraic sum of all the angular moments initial, that equal to how much? Final. Understood? Here what do we get? I1 omega 1 plus. Everybody, I1 omega 1 plus I2 omega 2, that equal to how much? I1 plus I2 into how much? Omega. This is the law of conservation of angular momentum. Now we can confidently say that U2 is assumed to be 0. Omega 2 is assumed to be 0. Then omega can be written as I1 omega 1 by how much? I1 plus I2. Now coming to here, V1 equal to V2 equal to how much? V. Then V can be written as, here we can write it as M1 plus M2 into V. You will get M1 plus M2 into V. This is how much? M1 U1. V can be written as M1 U1 by M1 plus M2. This is the common velocity in plastic collision, common angular acceleration, angular velocity, common angular velocity. So ఇప్పుడు చెప్పండి, ఒమేగా 1 ఎక్కువ ఉంటుందా, ఒమేగా 2 ఎక్కువ ఉంటుందా? ఒమేగా 1 ఎక్కువ ఉంటుందా, ఒమేగా 2 ఎక్కువ ఉంటుందా? ఇది పద్ధతిగా తిరుగుతా ఉంది. ఓకేనా? దానిపైన పుట్టుకున్న ఒక డిస్క్ కానీ పెడితే దాని యాంగులర్ వెలాసిటీ తగ్గుతుందా, పెరుగుతుందా? తగ్గుతుంది. అది అర్థమవుతుందా? Completed. This is all about conservation of angular momentum, conservation of linear momentum. Now coming to loss of potential energy. Loss of kinetic energy. Completed. దీని కింద రాయాలి. Completed. Of I1 omega 1 square, of I2 omega 2 square. Here what you will get? What is the final kinetic energy? Of I1 plus I2 into omega square. I1 plus I2 into ఏమైంది? ఓ ఏడ I2 అని రాయలేదా? ఓకే, థ్యాంక్ యూ. What is the final kinetic energy here? Of M1 plus M2 into V square. Of M1 plus M2 into V square. Clear? Now this part completed. Now change in kinetic energy. Here energy is not conserved. Okay na? Only momentum is conserved. Law of conservation of angular momentum. Law of conservation of angular momentum means what? Delta L equal to how much? 0. Law of conservation of angular momentum means what? delta L equal to 0. Tau net equal to how much? Tau net equal to how much? Delta L by delta T. Delta L equal to 0 then. Delta tau net equal to 0. External torque equal to how much? 0. Net external torque. This part can be written as L initial equal to how much? L final. That is the law of conservation of angular momentum. Similarly, what you can write? Generally, what is the impulse momentum equation? Tau net into delta T. Tau net into T equal to how much? L final minus L initial. Okay, now this is the impulse momentum equation in the rotary motion. So now coming to this. Now coming to here. What we will get here? Here, what is the conservation of angular momentum? Delta P equal to how much? 0. Delta P equal to how much? 0. Initial momentum equal to how much? Final momentum. Final linear momentum. So what is the F net equal to how much? Delta P by delta T. That equal to how much? 0. What is the impulse momentum equation? F net into T equal to how much? P final minus P initial. Okay na? F net into time equal to how much? F net into time equal to how much? M into V final minus V initial. So this is called impulse equal to change in momentum. Impulse. We can call it as linear impulse equal to change in linear momentum. Change in linear momentum. Linear impulse equal to change in linear momentum. What about this? Tau net can be written as tau net into T can be written as I into omega final minus omega initial. This is what? Angular impulse. Angular impulse equal to how much? Angular impulse equal to change in angular momentum. Change in angular momentum. This is called impulse momentum equation. Impulse momentum equation. Impulse momentum equation. Impulse momentum equation. Understood? Next. Completed. Impulse momentum equation in linear motion. Impulse momentum equation in rotary motion or angular motion. Now coming to laws of kinetic energy. Laws of kinetic energy. Chapandi. Here to here. Okay, laws of kinetic energy. Laws of rotational kinetic energy. Rotational kinetic energy. Laws of rotational kinetic energy. Laws of translational kinetic energy. Loss of translational kinetic energy. Loss of translational kinetic energy. Translational kinetic energy. So delta K equal to how much? Translational delta. This is rotational. That equal to how much? Initial kinetic energy minus final kinetic energy. Loss means what? Initial should be higher than the final. Okay na? What is the delta KE? Delta kinetic energy translational or linear kinetic energy initial kinetic energy minus final kinetic energy. Are you following? Initial minus final. What is the initial kinetic energy? Tell me. What is the initial kinetic energy? Half into I1 omega 1 square plus half I2 omega 2 square. Half I1 omega 1 square plus half I2 omega 2 square minus how much is obtained? Chapandi half I1 plus I2 into how much? Omega square. Half into I1 plus I2 into omega square. So what is omega? When you apply law of conservation of angular momentum, I1 omega 1 plus I2 omega 2 by how much? I1 plus I2 and omega 2 is not equal to 0. Then what you will get? Tell me. చెప్పండి ఏమొస్తుంది ఇక్కడ? half taken out. First you can take omega to 0. Then what you will get? If you take omega to 0, what you will get? There is omega 2 equal to 0. Then what you will get? Half I1 omega 1 square minus half into I1 plus I2 into I1 square, I1 omega 1 by I1 plus I2 whole square. Clear? అర్థమవుతుందా? అర్థం కాలే? This part is clear. అర్థమవుతుందా? Next half I1 omega 1 square minus this I1 plus I2. Denominator I1 plus I2 gets cancelled out. Half into I1 square omega 1 square by I1 plus I2. There. Okay na? So here half I1 omega 1 square taken out. Half I1 omega 1 square taken out. 1 minus I1 by I1 plus I2. I1 by I1 plus I2. That is equal to how much? Half into I1 omega 1 square into how much? I2 by I1 plus I2. I2 by I1 plus I2. Then what is the loss of kinetic energy here? చెప్పండి half into I1 omega 1 square. Here how much is obtained? I1 I2 omega 1 square by 2 times of I1 plus I2. I1 plus I2. This is the loss of rotational kinetic energy. Now we can write it as of m1 u1 square plus of m2 u2 square minus of m1 plus m2 into v square. V can be written as m1 u1 plus m2 u2 by m1 plus m2 u2 equal to how much here? u2 equal to how much here? 0. u2 equal to how much here? 0. Then of m1 u1 square minus of m1 plus m2 into, this can be written as m1 square u1 square by m1 u1 by m1 plus m2 whole square will come. Finally m1 m2 gets cancelled out. Then here of m1 u1 square 1 minus m1 by m1 plus m2. Then what is the loss of kinetic energy? How much is obtained? Chapandi. Change in kinetic energy equal to how much? Change in kinetic energy equal to how much? m1 m2 into v1 square by 2 times of m1 plus m2 m1 plus m2 m1 m2 by m1 plus m2 into u1 square I1 I2 omega 1 square by 2 into I1 plus I2. Now percentage loss of rotational kinetic energy. Percentage loss of rotational kinetic energy. Completed. Percentage loss of rotational kinetic energy and translational kinetic energy. Here we can write what is the percentage loss of kinetic energy? Delta kinetic energy by kinetic energy into 100 clear up. So ఇప్పుడు చెప్పండి, what is the delta kinetic energy? What is the delta kinetic energy? Half into I1 omega 1 square into how much? I2 by I1 plus I2 by I1 plus I2. Understood or not? ఇది అర్థమవుతుందా? ఇదే కదా అది. Of I1 omega 1 square into I2 by I1 plus I2. This is what? Initial kinetic energy. So this you can write it as kinetic energy initial minus kinetic energy final by how much? Kinetic energy initial into 100 equal to how much? I2 by that equal to how much? Into 100 I2 by I1 plus I2 into 100. That is the percentage loss of kinetic energy. Initial kinetic energy would be this. This is what? Initial kinetic energy. Initial kinetic energy. Now coming to percentage loss of kinetic energy. Why are you calling it as loss? You are writing initial minus final. Actually, we need to write final minus initial. That is negative. Negative. So here tell me, what is the percentage loss? Delta kinetic energy equal to how much? Half into m1 into u1 square into how much? u1 square how much? m2 by m1 plus m2. This is the initial kinetic energy. Initial translational kinetic energy. Understood? Delta kinetic energy can be written as kinetic energy initial minus kinetic energy final. Kinetic energy initial, kinetic energy final by initial into 100 equal to how much? m2 by m1 plus m2 into 100. That is in terms of percentage. That is in terms of percentage. Percentage loss of rotational kinetic energy, change in kinetic energy, fractional change in kinetic energy. What is the fractional change in kinetic energy? I2 by I1 plus I2. Fractional change in kinetic energy, I2 by I1 plus I2. Clear up? Motion. Concept of angular momentum in momentum. Concept of angular momentum in projectile motion. Angular momentum in projectile motion. Focus here. So we already discussed projectile motion. సో దీని మీద మీకు రేపు వీకెండ్ ఎగ్జామ్ ఉంటుంది కదా, 5 క్వశ్చన్స్ మినిమం వస్తాయి. ప్రీవియస్ ఇయర్ క్వశ్చన్స్ దాదాపుగా 6 క్వశ్చన్స్. ఈ కాంటెంట్ వింటేనే అయిపోతాయి. క్లియర్? 5-6 క్వశ్చన్స్ అటెస్ట్ తెచ్చిపోతాయి. ఇట్ ఈస్ ద వన్ లాజిక్. 40 minutes కాంటెంట్. ఏరా 40 minutes క్లాస్. ఫోకస్ హియర్. XY. This is Y. Focus. Now it is the projectile motion. Projectile motion. A particle is projected with a velocity V0 is given. V0 based on the previous year questions. Okay, now in most of the questions they gave initial velocity as the V0. Understood? So here it is what? Maximum point. This is the maximum point. So now I am taking, this is oblique projectile motion. Here it is ux equal to how much? V0 cos theta. So what about Vy? Uy equal to how much? Uy equal to how much? V0 sin theta. V0 sin theta. Now I am interested in calculating angular momentum. Here it is how much? Velocity V. Understood? Along this direction what you will get? Vx. Along this direction what you will get? Vy. Vx and Vy. Understood? Now, so we need to take position vector, some arbitrary point. It takes time t to reach this point. It takes time t to reach this point. Time t to reach this point. T is what? Less than u sin theta by g here. u sin theta by g here less than the time of ascent. అర్థమవుతుందా? Less than the time of ascent. Now tell me, what is the angular momentum of the particle? Angular momentum of the particle at position P about the point of projection. At P about the point of projection. This is what? Angular momentum. Angular momentum. Angular momentum of the particle. Angular momentum of the body or particle. Angular momentum of the particle at P. At P about the point of projection. Point of projection. Point of projection. That equal to how much? How to write the angular momentum? Mass of the particle. Mass of the particle or body. So that is equal to how much? L bar at point P about the point of projection. That equal to how much? Position of point P about point O crossed with velocity of the particle at point P. That is the velocity at point P. అర్థమవుతుందా? So how to get that? About point O means what? Vector should start from where? Vector should start from where? చెప్పండి. Vector should start from here. This is what? Vector should start from here. This is the position of point P about point O. So how to write this? Here to here, here to here, small x, x. This would be how much? Y, y. In time t, in time t. This is xi cap, yj cap. చెప్పండి, how to get velocities and distances along x and y direction. How to get along x and y direction? First take along x direction. Along x direction. This is along y direction. Along x direction and y direction. Clear up? So now tell me, Vx equal to how much? V equal to how much? U plus AT. V equal to how much? U plus AT. So we already know that Ax equal to how much? 0. Ay equal to how much? Ay equal to how much? Minus G. తెలుసా తెలీదా ఆయన వరకు? సో ఇప్పుడు చెప్పండి, along x direction, along x direction, along y direction. So here Ax equal to how much? 0. Vx equal to how much? Ux equal to how much? V naught cos theta. V naught cos theta. Then Uy equal to how much? Vy equal to how much? V naught sin theta. V naught sin theta minus G into T. Correct or not? Correct or not? అర్థమవుతుందా? Here, what is the Vp bar? Velocity at point P bar equal to how much you can write? V naught cos theta. V naught cos theta I cap plus చెప్పండి V naught sin theta minus GT J cap minus GT J cap. So Vp bar equal to how much? Yeah, Vp bar equal to how much? V xp plus EXP I cap plus Vyp j cap Vxp I cap Vyp j cap. This is xp. This is yp. xp yp. Understood? Are you following or not? X equal to ut plus x equal to rs s equal to ut plus half at square s equal to ut plus half at square. Then what you will get? X equal to how much? V naught t. This is how much? 0. X equal to how much? V naught. X equal to how much? V naught cos theta t. What about y? Along y direction.
V naught sin theta t minus half gt
Y
square.
equal to how much? V naught sin theta t minus half gt square minus half gt square. What about the position vector? What is the position vector? Position of point P about point O. That is xi cap plus yj cap xp yp xp yp. Okay now up to point P xp yp. That is the mass m. What is this point? xp comma yp. That is the point xp comma yp. So now tell me what is the position vector? Position of the particle P about point O equal to how much?
Cos theta of t.
xp yp na xp I cap plus yp j cap. ఎంత వస్తుంది? V naught cos theta into t. This is I cap plus V naught sin theta. V naught sin theta into t minus half gt square. This is how much? J cap. This is how much? J cap. Are you clear or not? Now, what is the angular momentum of the point P about the point of projection? Angular momentum of point P about the point of projection. Completed. This part completed. ఏమి రాసుకున్నారు మీరు? ఇప్పుడు రఫ్ లో రాసుకుంటారో మళ్ళా మీరు మంచిగా రాసుకోవచ్చు. స్టడీ అవ్వండి. బుక్ అయిపోయింది. ఆ లెవెల్లో రాసుకున్నారు. Completed. This part completed. Now tell me how to write this. Angular momentum of the particle P about point O, point of projection, cross product IJK, I cap. So I cap ఏమొస్తుంది? Position vector V naught cos theta t. V naught cos theta t. After that J cap what you will get?
V naught sin theta.
V naught sin theta t minus half gt square. This is K cap. What about velocity? V naught cos theta. This is how much? V naught sin theta minus gt will get 0, 0. When you cross multiply, what you will get? m into so what we will get v naught square sin theta cos theta into t v naught cos theta into t minus inta v naught cos theta into
CT.
v naught cos theta into gt square. Yes. Minus of చెప్పండి v naught square sin theta cos theta into t sin theta cos theta into t minus v naught cos theta into of gt square. Are you getting the same? Are you getting the same? This part and this part cancelled out. These two gets cancelled out. Correct or not? Then finally, how much is obtained? చెప్పండి ఏమొస్తుంది ఇక్కడ యాంగులర్ మొమెంటం ఎట్ పాయింట్ పి about point O. What you will get? Okay, angular momentum at point P about point O. About point of projection equal to how much? ఎంత వచ్చింది చెప్పండి m into
half with plus minus half v naught
ఇక్కడ ఏమొస్తుంది
minus
m into gt square v naught cos theta
by 2
v naught cos theta k क्या v naught cos theta this is how much 1/2 minus 1 correct or not into k cap are you following next item position of point p about point O that equal to how much minus m gt square by 2 into v naught cos theta k cap. This is the angular momentum of the particle P about point O. Angular momentum of the particle P about point O. It is along negative z axis. It is along negative z axis. Along negative z axis minus mg t square by 2 into v naught cos theta k cap minus mg t square by 2 into v naught cos theta. Clear up now. Completed now. Is it done? అయిపోయిందా now here angular momentum of the particle at m about point O. Angular momentum of the particle at maximum height. Angular momentum of the particle at maximum height. maximum height. About the maximum height, yeah. About the point of projection. About the point of projection. About the point of projection. Go. అర్థమవుతుందా? So in this, how to get maximum height about point O? చెప్పండి. T becomes how much?
2 sin theta by g.
Time of ascent equal to how much?
Sin theta by g.
U sin theta by g. So then substitute T equal to TA. Then what you will get? Lm about point O. That equal to how much? Minus mg. Minus mg by 2 into T equal to how much? So here V0 sin theta by g. U sin theta by g means what? V0 sin theta by g. V0 sin theta by g whole square. V0 cos theta into k cap. Are you getting the same? U equal to how much? U equal to how much? V0. U equal to how much? V0. Then how much is obtained? Minus mg into V0 cube by 2g square. V0 square into, this is sin square theta into cos theta. Sin square theta into cos theta. K cap. G gets cancelled out. Minus m into V0 cube by 2 times of g into sin square theta cos theta k cap. That is the L at m about point O. About point O. About point O. అర్థమవుతుందా? నెక్స్ట్ L M about point O. At M about point O. That equal to how much? M times of minus M times of V0 cube by 2g sin square theta into cos theta k cap. Are you getting the same? Are you getting the same? So how to represent that part? Angular momentum at M. So here, what is the velocity here? This is how much? Vy equal to how much here? 0. Vy equal to how much here? 0. Vx equal to how much here? Vx equal to how much here? Ux. V0 cos theta. V0 cos theta. Okay na? So it is hitting the ground. Position of point M about point O. So this is how much? Xm, Ym. This is Ym, Y maximum, H maximum. That equal to how much? U square sin square theta by 2g. This point is how much? Xm comma Ym. Xm comma Ym. Understood or not? So now we need to talk about hitting the ground. Okay na? While hitting the ground, so this will come like this. This is V0. This is Ux or Vx. Vx along this direction. This would be theta. Understood? This is the point Q. When it is hitting the ground, what is the position of the particle? About position of the particle at point Q. About point O, that is equal to how much?
Square sin to the plane.
Range I cap. R equal to how much? Range. R equal to how much? Range. range r equal to how much?
Sine 2 theta
U
by
square sin 2 theta by g. U square sin 2 theta by g. How to get angular momentum of the particle while hitting the ground? That is at point Q. Angular momentum of the particle while hitting the ground. While hitting the ground. Hitting the ground. Hitting the ground. While hitting the ground. At point Q. At point Q. About point of projection O. About point of projection O. Then what you will get? T becomes equal to how much? Time of flight. Time of flight. Time of flight. Into 4. Into 4. Are you clear? At point Q. About point O. At point Q. About point O. 2 2 jar you will get. Then finally 2 times of this. 2 times of this. Understood or not? Understood or not? Minus 2 times of m e naught cube into sin square theta cos theta by g. Are you following or not? Now we need to talk about this. Completed. 2 sin theta cos theta can be written as sin 2 theta by g. M into V naught square. Completed. అయిపోయిందా ఇది this part completed. Now how to write this? From here to here what we will get?
Minus mv naught square.
L at point Q about point O can be written as చెప్పండి
Minus mv naught cube.
minus m into
Not cube.
V naught
Cube.
sin theta V naught sin theta by G
so P naught
m into V naught
Sin theta.
sin theta by G. Here what you will get?
here right
V naught square into 2 times of
sin theta
sin theta cos theta. This is how much? G. V naught square 2 sin theta cos theta by G. Are you following? Then this is K cap along K cap minus m into V naught sin theta into this can be written as range K cap. That is the L at point Q about point O. L at point Q about point O. అర్థమవుతుందా? Now method 2. How to get the same expression by using method 2. Time ఎంత అయింది? How to get the same expressions by using method 2. Completed. చూడండి ఇక్కడ now we are interested in about the point of projection. See this xy. This is how much it is projected. It is projected like this. Particle is projected v naught. This is theta. Ux and uy. Ux equal to how much?
cos theta. V naught cos theta.
V naught cos theta. Uy equal to how much? V naught sin theta. Okay, while hitting the ground, velocity how much? ఇక్కడ V naught తో ప్రొజెక్ట్ చేస్తే అదే V naught తో బయటకు వస్తుంది. అర్థమైంది కదా? అది క్లియర్. దిస్ ఈజ్ ఈక్వల్ టు హౌ మచ్?
V naught cos
V naught cos theta. This is how much? V naught sin theta. V naught sin theta. Position of the particle. What is the position of the particle? At Q. Position of the particle at Q. That is equal to how much? Range I cap. Range I cap. అర్థమైందా? Now, what is the VQ bar? What is the VQ bar? చెప్పండి.
V naught cos theta I cap plus
V naught cos theta
I cap.
I cap minus
V naught sin theta J cap.
V naught sin theta J cap. Position of this is what? Angular momentum. Angular momentum of the particle at point O, point Q, about the point of projection. Position particle Q about point O crossed with velocity of the particle at position Q. అర్థమైందా? ఇలా అయినా రాయొచ్చు, డైరెక్ట్ గా ఇలా కూడా రాయొచ్చు. M into R into V perpendicular. M into R into V perpendicular.
V naught
Which
sin
one? Which component is perpendicular to R?
V naught
Which component is perpendicular to R? Then that is what? M into what is the R? What is the R? R would be the range. V naught sin theta.
minus J
It
cap.
is along which direction?
Minus J cap.
Minus K cap. Along which direction you will get? How to get the direction?
I cap
How to
plus
get the direction? This is R bar. Downward how much? V bar. Is it clockwise or anti-clockwise?
Clockwise.
Minus K cap. First R bar, next V bar. First R bar, next V bar. It is inward or outward?
Inward.
Inward. Understood? Are you getting the same? MR. V naught sin theta. MR. V naught sin theta. R equal to how much? MR. V naught sin theta. Are you getting the same? అర్థమైందా? Next. Coming to at maximum height. At maximum height. At maximum height. Method 2. Maximum height. Maximum height. M. At point M. So now the particle is at maximum height. Particle is at maximum height. What is the position of the particle? What is the position of the particle? At M. About point O. About point O. Position of the particle about point O. Understood? So now, what is the velocity at this point?
Vx.
What is the Vm?
J cos
Now tell
theta
me, Vy equal to how much?
V naught sin.
Vy equal to 0. Vx equal to how much? Ux. Ux plus Ax into T. Ux plus Ax into T. Ax equal to how much? 0. Vx equal to how much? V naught cos theta. Vx equal to how much? V naught cos theta. That is Vm, right? That is the Vm bar. Vm bar equal to how much? V naught cos theta. V naught cos theta. I cap. What is the position of the particle? Here it is how much? Xm. This is how much? Ym. Ym. Understood? Now. So this is how much? What is the position of the particle? At point 1, about point O.
X I cap plus Y.
Xm. I cap plus Ym. J cap. What is the angular momentum of the particle at maximum height about the point of projection? At maximum height about the point of projection. Position of the particle at m about the point of projection. Velocity of the particle at position m. అర్థమవుతుందా? Then what you will get, tell me? This is equal to how much? M into Ijk. V naught cos. What is the position? Xm Ym 0. This is how much? V naught cos theta 0 0. Finally, how much is obtained? M into minus V naught cos theta Ym K cap. K cap. What is the Ym? H maximum. H maximum. That equal to how much? V naught square sin square theta by 2g. If you substitute everything here, what you will get? L at point M about point O can be confidently written as చెప్పండి minus m times V naught cos theta into V naught square sin square theta by 2g. Sin square theta by 2g. K cap. Then how much is obtained? చెప్పండి Lm about point O minus m times of V naught cube by 2g. M times of V naught cube by 2g into sin square theta cos theta K cap. Understood? Are you getting the same? Check it once. Are you getting the same? Next. ఏమైందండి? 5 minutes. Next. If you take at theta equal to 45 degrees, when if theta equal to 45 degrees, what you will get? If theta equal to 30 degrees, what you will get, tell me? Theta equal to 45 degrees, what you will get, tell me? Position of M about point O, that equal to how much? Minus M V naught cube by 2 times of G. This is how much? 1 by root 2 whole square into 1 by root 2 in K cap. Finally, enta 4 root 2 at point M about point O. How much is obtained? Minus M V naught cube by 2 to the 4 root 2g. That is K cap. Angular momentum at maximum height about the point of projection when theta equal to 45 degrees, when theta equal to 30 degrees, angular momentum at maximum height about point of projection. How much is obtained? Minus m into v naught cube by 2g into how much? Sin 30 how much?
1/2.
1 by 2 whole square. Cos 30 how much? Root 3 by 2. K cap. No square. Understood? This is how much? Minus root 3. M into V naught cube by 2 to the 4. 4 to the 8 to the 16. 16G. K cap. That is the angular momentum at M. About point O. These two are previous year questions. Okay now, if they ask, if they ask at point Q, about point O, what you will get? What you will get?
minus mv naught sin theta r k cap.
That is different. That is enough. This is all about some funda related.